Hi guys, Digital Principal and Computer Organization. The subject code is CS3351 Unit 2 Synchronous Sequential Logic. In this video, I am going to explain you register, what is meant by register and type of register used in the digital circuit. Register is used as the storing element in the digital circuit. So it is used as a storing element. If one flip-flop is used in the digital circuit means it's going to store only one bit of data. If you want to store more than one bit, what you can able to do is you can construct a group of flip-flop. This group of flip-flop is known as register in digital circuit. For example, if you are going to store the 8-bit data means you need to construct the 8-bit of flip-flop. 8-bit of flip-flop. This 8-bit of flip-flop is known as register in that particular digital circuit. In simple word, the group of flip-flop is known as register and register is used to store the data in the digital system. The n-bit register consists of n number of flip-flop. It means if you are going to construct 8-bit register means so 8-bit register. This is 8-bit register means how many flip-flop is going to use is 8 flip-flop. 8 flip-flop is used to construct the 8-bit register. And it is capable of storing the 8-bit word. Next one is shift register. What is meant by shift register? If you want to move the data from one flip-flop to another flip-flop. One flip-flop to second flip-flop or some other flip-flop in that same digital circuit. The register is used to allow the data transformation is known as the shift register. With the help of the shift register, we can able to transfer the data from one flip-flop to another flip-flop. Usually, the register will be classified into 4 types. First one is serial in, serial out. Serial in, serial out. Serial in, parallel out. Parallel in, serial out. And parallel in, parallel out. In, serial out shift register. So you are going to give the input in serial mode and the output is going to provide in that serial mode. In serial in parallel output shift register, the input is given in serial and the output is provided in parallel. In parallel in serial output shift register, the input is given in parallel and the output is provided with serial. In parallel input, parallel output shift register, the input is given in parallel mode and the output is given provided with parallel output. First one is serial in, serial output shift register. Usually, in this serial input, serial output shift register, the all the Q3, Q2 and Q1 will be in the reset condition that is equal to 0. If an entry of the 4-bit binary number is 111 is made into the register, this number should be applied to the DIN. So this DIN bit is considered to be an primary input of that old circuit. The D input of flip-flop 3, that is D3 is connected to the serial data input of D in. I will explain with this in block diagram. So see here this block diagram. This is D in. Okay, this D in is the initial input. That initial input is connected with the D3. Okay. Afterwards, this is the flip flop, third flip flop. In this serial input, serial output shift register, we will use 4 flip flop. Flip flop 0 to flip flop 3. So in this third flip flop is considered to be an initial input, and D3 is connected with this initial input of D in. Afterwards, this Q3 is going to act as an input of D2. So Q3 is an output of flip-flop 3. Flip-flop 3. This output is going to act as an input of D2, that is flip-flop 2. In simple word, the flip-flop 3 output is going to act as an input of flip-flop second flip-flop. The same procedure is followed between this flip-flop 2 and flip-flop 1. This flip-flop 2 output is going to act as an input for flip-flop 1, and this flip-flop first 1 output is going to act as an input for flip-flop 0, and the Q0 is an final output of the serial in serial out register. And usually the flip-flop is connected with the clock, and this clock is usually in the negative edge. What is meant by negative edge? If the flip-flop is given with the value of here. So this is the negative edge edge clock. The clock is triggered with negative edge in this flip-flop. What is the operation of this serial in serial out flip-flop? Initially, all this Q3, Q2, Q1 will be given as, and Q0 is given as 0, and apply the least significant bit number to be entered into the D in. That is, D in is the initial input that is connected to the D3, and you need to give as 1. Apply the clock and the first falling edge of the clock. Falling edge means that is negative edge. That is negative edge. And the flip-flop 3 is set and store the word in the register. That is, first of all, you need to give 1, and the remaining all flip-flop values will be 0. So first you will get a value of Q3 is 1, and Q2, Q1 and Q0 as 0. Afterwards, the similar procedure is followed to give an input to get output. So this is 1. Afterwards, Q2 is 1, and Q3, Q1 will Q2 and Q1 and Q0 will be 0. The clock pulse is activated with the negative edge. And in the next time, the flip-flop 2 will be in set condition. In before, the flip-flop 3 is in set condition. Afterwards, you need to give flip-flop 1 in the set condition. So you need to give 1 as an input here. Afterwards, the remaining 3 will be 1, and the last is given as the 0. So Q3, Q2, Q1 and Q0 is 1, 1, 1, 0. In our first operation, we will set flip-flop 3 as in set condition. Afterwards, flip-flop 2 in set condition. Now, flip-flop 1 will be in set condition, and the output will be get given as 1110, and the final one, the flip flop 0 is in state condition, and the final output will be get as like this, that is 1111. The fourth negative clock edge arriving, and the stored data in the register is 1111. In this time, the flip flop 0 will be in the set condition. This is the truth table of serial in, serial out register. So negative clock, why we are using the downward direction? Because in this register we will use the clock in negative edge triggering mode. That's why we will mention the symbol in downward direction. And here you need to mention that D in is Q3. Afterwards Q3 is equal to D2 and Q2 is equal to D1 and Q1 is equal to D0. Afterwards the Q0 value. In all the time you are going to give an 1 as the input in D in is equal to Q3. Afterwards 0, 1, 1, 1, 1. Afterwards this 2 will be 0 and 1, 1, 1. And when Q3 equal to D0, you will be given as 0, 0, 0 and 1, 1. And the final Q0 is given, the final output will be, that is 4, 1 is will be provided as an output, and it is stored in that register. This is the waveform of this stored output. First we will get given as 4 0. So D in is 0, 1, 2, 3, 4. This is 4 plus. So you need to mention with wavelength. Afterwards 1, 0, 0, 0. This is Q1 value and Q2 value, Q3 value. Afterwards the final output is stored as 1, 1, 1, 1. Serial input and parallel output. In serial input and parallel output, the input is given in serial mode and the output is provided with the parallel mode. Four clock cycles are required to load a 4-bit word. And the speed of the operation in serial in parallel out mode is same that as the previously explained serial in serial output mode. This is the block diagram of serial in parallel output mode. So this Q3 is given as in output is given as the input, and it is will be connected parallel output with all this Q0, Q2, Q3 and Q0. Sorry, Q2, Q0, Q1, Q2 and Q3. And the flip flop of the one of the end is connected with the clock, and this is D in, D2, sorry, D3, D2, D1 and D0. In this parallel input and serial output, there will be a two mode of operation. One is shift mode and another one is the load mode. So this is the operation diagram of serial in parallel output. See here, this input is connected with this AND gate, sorry, OR gate and AND gate, and this is the B0, B2, B1, B2 and B3. These all will be the parallel input is going to connected with this 4 flip-flop. When the load mode is low, that is 0, the AND gate of 2, 4 and 6 became active. They will pass the B1, B2, B3 to the corresponding flip-flop. Usually it is given in the 0 value. The AND gate of 2. This is the 2, 4 and 6 is became active, and it will pass the B1, B2 and B3 to the corresponding flip-flop. So this one of this input is connected with here, and this is connected with this flip-flop, and this output is connected with this flip-flop. Here the parallel loading is take place in this load mode. Afterwards, in shift mode, when the initial input is given as 1, the AND gate of this 2, 4 and 6 is became inactive. So it is become inactive. If it become inactive means the parallel loading of data is impossible. But here the remaining AND gate of 1, 3 and 5 is become active, and the parallel loading is possible when this 3 AND gate will be become active. Afterwards, the serial parallel in serial out operation is take place. Next flip flop is parallel in parallel out. It is similar to the serial in parallel out. Here the both will be the input is given in parallel mode and the output is provided with the parallel mode. So the same construction of the flip flop is take place to the like the previous flip flop. There will be a connection of B0, B1, B2 and B3 is a applied data input of D0, D1, D2 and D3 of 4 flip flop. Afterwards, you need to give the clock pulse in negative way, and the input binary will be binary bit loaded into the flip flop. So this is the block diagram of parallel in parallel out. See here in this parallel, these are the parallel input and this is the parallel output. So this is input, parallel input, B0, B1, B0, B1, B2 and B3 is given as the parallel input, and this Q3, Q2, Q1 and Q0 is the parallel output of this parallel in parallel output shift register, and the same procedure operation is followed in this parallel in parallel output shift register. And what is meant by universal shift register? The universal shift register is it can able to do the all the operation. For example, if the shift register is which is shift the direction data in only one direction is known as unidirectional shift register. If the shift register is used to transfer the data in both the direction means it is known as bidirectional shift register. The shift register which is going to perform the all the function is known as universal shift register. The shift register is this universal shift register is capable of performing the following operation: parallel loading, left shifting and right shifting. So if the data is transferred from one flip flop to into another in left means this universal shift register can able to do the process like that. It can able to transfer the data from, so if it can able to transfer data from one flip flop to another in left side means that is known as left shifting. If the data is transferred from one flip flop to another flip-flop in right direction, means that is right shifting. Afterwards, it can able to do the parallel loading. The mode control input is connected to the logic 1 for parallel loading operation. Wherever it is connected 0 for the serial shifting. With mode control pin connected to the one of the control pin is connected to the ground, the universal shift register can act as the bidirectional register. It means it can able to transfer the data from in both the direction, in left side as well as in right side. For serial left operation, the input is applied to the serial input which goes to the AND gate 1, whereas the shift right operation, the serial input is applied to the D input. This is the block diagram of universal shift register. See here, this is the mode control and serial input of AND gate 1, 2, 3, 4, 5, 6, 7, 8. So these are all connected in the connected as parallel input and clock. Here we will connecting the two clock 1 using for the right shift and clock 2 is using for the left shift. And this is the mode control of AND gate 9 and 10. Afterwards, this is the input and Q3, Q2, Q1 and Q0 will be connected in the connected as an output of this 4 flip flop.